Hello fellas, it's me again. I've got this nice spot lamp to play with. Let's have a closer look, shall we? If we take a peek down the front, we can see straight away there's no ordinary lamp in there, but we'll get to that in a few minutes. Here's the rear of the control gearbox. It's a Thorn OQ1000 lamp CSI, which stands for compact source iodide, 1 kilowatt, made in Great Britain, danger high voltage, switch off before blah 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 blah. Let's have a look inside. Anyway, traditionally in something like this, one would expect to find a ballast, an igniter, some power factor correction capacitors, but in this, the only thing in here is the high voltage transformer for the ignition pulse. The circuitry on the rear is a relay, but we'll have a look at that in a minute. Some of you might have already seen the wiring and noted that there are 4 conductors. It's not 3-phase, all it is basically our neutral, earth, live from the ballast, and this black one is a trigger for the igniter. This obviously predates solid state igniters such as this. Let's see if we can get that on there. There we go, yeah, predates stuff like this. And in the control gearbox, which would be mounted remotely, there would be a ballast, a load of power factor correction capacitors, and also a time switch. So when voltage is first applied, it engages the igniter for 3 seconds and then switches off. Let's have a look at the back of the igniter. There's the rear of the igniter. It's a Thorn high voltage pulse transformer for starting 1000 watt compact source iodide lamp, danger high voltage, catalogue number AME 47077, made in Great Britain. The pin out there at the back, and this relay here, HT lead by the way. That's some quite hefty insulation. I believe these kick out 25,000 volts. Let's have a look at the lamp. The lamp compartment is accessed by these simple 3 catches. Now if this was in service, you'd remove the lower part so as not to disrupt the aim. Well, obviously I can't. Oh, there we go. Let's have a closer look at that lamp. Here's the lamp itself. It's a Thorn 1 kilowatt compact source iodide parabolic aluminized reflector lamp. It wants between 70 and 85 volts and draws 15 amps from the ballast. The reason why these are so good is because if you look at this traditional 1000 watt metal halide lamp, next to it for scale, you can see that the single line ended discharge tube in this is extremely small and therefore allows it to be placed directly in the focus point of this extremely compact reflector. Now the lamp itself is only about, I don't know, 78,000 lumens, but because it's in the middle of this so perfectly, the luminous intensity is in the millions of candela, which is why these are popular. Well, they were popular in the 70s and the 80s for lighting football pitches, monuments, castles, flagpoles, whatever. Anywhere where you needed a long throw of lamp, these were your ones to get. Let's have a closer look at the rear. Yes, we've got a nice big chunky G38 bipin. Not sure if you'll be able to make out the edge there. Thorn 1 kilowatt CSI, made in Great Britain, and there's some batch numbers, day codes, etc. These are all in the short art department, were all handmade, so these were all tested, and the numbers of the arc tube and the reflector should match, which they do. Anyway, time to stop waffle, time to light the sky up. Just a quick close up there of the arc tube. It's extremely compact for the wattage. Obviously the orange material you can see deposited on the wall of the arc tube would be the metal halide salts, probably somewhere along the lines of scandium, indium, sodium, that sort of stuff. I'm not sure in the chemistry, like, so don't quote me on that, but I imagine the pressure inside there would be silly. I mean, these have only got a life of a couple of thousand hours, so the temperature and the pressure in there must be silly, and I really wouldn't want to be near one of them when you went bang. Anyway, just gotta wait till it gets dark and we can have some fun with that big lamp. Misty. Right, here's the control gear I'm going to be using to fire it up. The lamp itself wants 15 amps and the arc voltage is, well, the spec is between 70 and 85 volts. Now I've got a 1000 watt sun ballast which gives us 10.3 amps and a high pressure mercury vapor lamp which gives us 3.4 amps. These together in parallel gives me just over 15 amps, and the lamp voltage stabilizes at between 82 and 83 volts, so it's quite happy running on these. Obviously the instructions for the normal ballast that you normally use with it says to use 7 25 microfarad capacitors for power factor correction. I've only got 4, but that'll work anyway. Anyway, let's have a look. Let's light that candle. That buzz you heard was the igniter cycling. Pulling 12 amps from the mains, 18 amps from the ballast. Oh yeah. Oh, just tweak the beam a bit. Not even a full power yet. Try zooming in a bit. You can't really see how far it's going because of the moisture in the air, but yeah, it's lighting up that field. That field is quite a distance away. Yeah, that's bright. Let's try a different angle. Absolutely nukes the camera. There's a lot of heat coming off this. Total system power is twin chokes, not very efficient, 1283 watts. Anyway, I think I've had enough fun with this now. Let's give it a rest. Bye bye.